Okay, so recently Microsoft had their Build conference and they announced a lot of things there, including new Copilot Plus PCs and a whole bunch of different things around the sort of Copilot ecosystem that they've built. One of the things that was really interesting, though, was they launched some new Phi models. So these are the Phi-3 models. Specifically, the one I'm going to focus on today is the Phi-3 Vision model. So that they really have turned this into a family of models. You've got everything from the really tiny ones, I guess, like what they had in the past, to the sort of Phi-3 mini, which is now 3.8 billion. I guess doesn't seem that mini anymore compared to some models out there. The Phi-3 small is 7 billion. And the Phi-3 medium is 14 billion. But the one that I'm really interested in for this video is to look at the Phi-3 Vision 4.2 billion parameter model in here. So interestingly, they talk about how they've optimized these models to basically run at the edge, right, with sort of Onyx runtimes and stuff like that. But also they go into a bit of how they actually did the multimodality in here. Now, it does seem that they've taken a different approach to what Google was doing with PalyGemma and stuff. PalyGemma, I guess, in many ways, is actually more of sort of a research release in that we don't have super well fine-tuned instruction models. They've gone for, I guess I would call it a lighter fine-tuning, and then they've set it up so people could actually take it themselves and do a lot more fine-tuning with it. It does seem that this Phi-3 Vision, it's actually built to do a number of key things, including things like the ability to look at graphs and understand different things in diagrams, as well as do sort of your standard visual question answering kind of stuff there. And we'll have a play with it in code in a little bit. Of course, the interesting thing about it, the input's going to be text and image, because that's what multimodality is when you're giving it away for free. We've yet to see anyone also put in, audio out, or anything like that. I'm sure that'll come at some point, but unfortunately not yet. The interesting thing is they've got a couple of versions of this, with one of them with a context length going out to 128,000 tokens in there. So that's quite impressive there. So the training of this is only 1.5 days according to their stats sheet, but that's 1.5 days of 512 H100s. So certainly it's had a lot of training, for doing this kind of thing. So I think what they've done is take one of the previous models and then modified the architecture. And they say that they've trained on 500 billion vision and text tokens. So we'll need to have a look in when we play with the code, actually how many tokens things work out to be and stuff like that in here. Again, this is an open weights release. It's not an open source release. You still have to agree to their terms, etc. So it is interesting looking at the technical report that they're still working with the training methodology is still using this sort of sequence of works initiated with the textbooks are all you need paper, which is one of the earlier Phi papers. And the key thing with that, and it does seem with this as well, is the use of synthetic data to get better results out of your training. And so this is actually one of the things that a lot of people suspect is what's going on with the GPT-4o, GPT-5, Gemini 2, and stuff like that, is that there's a large advantage that seems to come with training on synthetic data that you can kind of control things a lot more. On top of probably other data as well, although the Phi models with their small amount of data seem to do less of that. So when we come and look at the technical specifications for Phi-3 Vision, sure enough, we can see in here that it's kind of similar to PalyGemma in that they've got a image encoder, which I explained in the previous video about that. So they're using a clip encoder here. And then they've got language model or transformer-based language model. In this case, they're using the Phi-3 Mini 128K instruct. It is interesting that they mentioned that they're interleaving the images and text, but there's no particular order for image and text tokens. So it's not like it's forcing the images to be at the start. It seems like what they're saying is that you can have some text, you can have some image tokens, you can go back to text, that kind of thing. By the looks of it, they've also done quite a bit of synthetic data derived from OCR of PDF files. So that's something that could be really interesting. And we'll have a play with this, is that if you can get one of these small models that can actually be really good at OCR, you can then fine tune it for your particular task, like reading receipts, like doing various things like that. So the training process, again, they mentioned the sort of 500 billion tokens in here. And it does seem like once they've done their pre-training like that, the post-training which, remember, post-training is basically your supervised fine-tuning, your alignment, probably a few other things that people don't really want to talk about too much publicly. But you can see here they've got supervised fine-tuning and sort of DPO going on for the alignment. And that was a rather small amount of only sort of 15 billion tokens, although it's still pretty decent size for doing this sort of supervised fine-tuning or instruction tuning, as we sometimes call it. So I think the best thing now is let's just jump in and have a play with it and see how it actually goes. Okay, so if we jump into the code and have a look at just getting this Phi-3 Vision model working, it's pretty basic. So if you've watched the Phi Demo video, you'll see that there's a lot of things the same in here. One of the things that the Phi-3 can make use of, though, is the flash attention, which can make it a little bit faster and stuff as well. So I'm also using the HF transfer package just to be able to download the model quicker. It's something that you should be using on all your sort of transformers stuff now. It just makes loading weights a lot quicker if you're downloading something from Hugging Face, especially when you're talking about the really big models, which this isn't actually. So you can see here, we're basically just loading up in full resolution. And when we look at it, it's only using 8 gigabytes of memory in here. So I've got an L4 GPU on here. I could have easily gotten away with a T4 in hindsight. I just had this already set up. But you'll see afterwards, I'll go through it in 4-bit and it gets even smaller when we're using it in 4-bit. So the prompt format here is basically that we pass in the image and then the prompt, and then we can structure this out if we want to. They've got an example of doing this with their image in here. And you can see that the messages basically just go, what is shown in this image? Then you've got the assistant coming back. And then you've got, okay, provide some insightful questions to spark discussion. And we run this through. This is going to go through our processor. So remember, our processor basically is like the tokenizer for the actual text prompt, but also for the image as well in here. So you see here, we're basically tokenizing the text, and then we're passing that in, and we're processing the image, which in many ways is also tokenizing the image in here. I'm going to set it to basically just be 512 new tokens. We've then got a standard generate, and then we use the processor to basically just decode things out here. And you can see that the answer for the question up here, provide insightful questions to spark discussion. We got here some questions out. What are the most significant barriers to meeting preparedness according to the respondents? So this is really quite nice about this model, is that you can do full vision, question answering, and you can also take advantage of the Phi-3 language model to sort of process that, or to sort of add to that. You can ask it things, what in an image, but then you can ask it, okay, what does that mean? And I've got a sort of example at the end that I'll show you with that, where it's using a receipt and it's taking an abbreviation and working out, well, what does that actually mean in here? Anyway, I set up a Vision QA pipeline here, just taking what we had above, sticking it into a function. We've got one of the images from the Phi Demo notebook in here. When I ask it what is shown in this image, the image displays a variety of flowers, including large pink flowers with a bee on it. So it's certainly getting the details there. I was curious to see, okay, how good was the OCR? And could it work out different things in here? So I took one of the thumbnails from my old videos, put it in, ask it, okay, what is shown in the image? The image shows a llama wearing a scarf. I'm not sure it's a scarf, but even I'm not sure about that, so I wouldn't hold that against it. Holding a smartphone, which I thought was pretty good that it got that. There are also logos for Llama 3 and Phi-3, and the text reads function calling with local models. So you can see that it's pretty much got all of that correct. And the only follow-up that I was thinking that it didn't get was maybe the sunglasses. So I asked it, what color are the sunglasses? The sunglasses are blue. So I was very impressed with the result for that. You could imagine this is a really good sort of way to basically set up a pipeline to interpret a lot of things in images as we're going through it. Next up, I was curious. So this is one of the tests that I've used for a lot of vision models. The Phi Demo probably does the same as the Phi-3 in this one, in that they both can get what this is about. This image shows an aerial view of an airport runway with multiple airplanes parked, but they both get the number of planes wrong in here. Now, you could go through and work out, okay, it's saying 12, and I've forgotten what Polygemma said, but it also got the number, I think it got the number closer, but it was still actually wrong. And if we count these out, we can work out that there are more than 12 in there. It could be because it's not counting some of the small ones. So if we go for the big ones, we've got 6, 8, and 4, which gives us 12, and it's missing out these smaller ones in there, which is possible, but it's still wrong, right? In there. When I'm curious to see, one of the cool things with the new Gemini Pro models is you can actually ask it for bounding boxes of things. So I was curious to see if this could actually do it. But it not only did it not give it, it didn't even attempt it, which I thought is interesting as well, that it basically just says it's beyond its capabilities. I'm not equipped to perform. Now, I do wonder, could you make a data set that you could fine tune some of this into it in there? Anyway, next up, I thought I would just take a receipt. So I just downloaded a receipt from the internet. You can see that it's got sort of bread, peanut butter, ground chicken, maybe. There's a number of different things on there with different prices. Okay, I start off by asking it, what is this? And sure enough, it gets that it's a Walmart receipt. When I ask it, how much is the bread? It said the bread is priced at $2.88. So let's just come up and look at that. Sure enough, the bread is $2.88 in here, which I'm pretty impressed about. What cost $1.88? So it says the cost of $1.88 is for the eggs item. Sure enough, $1.88, the only thing with $1.88 is the eggs. So it's getting that right. And at this stage, I'm starting to think, the next one I asked is, okay, how much is the peanut butter? Now, notice that it doesn't actually say peanut butter anywhere. It's got PNT, BUTTR in there. It has no problem of working out that that means that it's peanut butter. So it's basically here, the price of the peanut butter is $3.84. Let's look at that. Sure enough, it's $3.84. So at this stage, I was really thinking, okay, how can I get it to get something wrong? So I asked it, how many peanut butters did I buy? It says you bought 3, and we can see here that actually the receipt is for 4, not 3 in here. So that one, it got wrong. All right, so then after that, what I thought is, okay, let's try the whole thing in 4-bit, because I know a lot of people want to run this in 4-bit. I'm surprised that this is not in Ollama yet. It seems to me that this really should be in Ollama, the way it's doing so well. So I tried it in 4-bit, and you'll see, look at the memory usage there. We're under 3 gigabytes of memory for this, which is pretty amazing in here. So again, I asked it the same kind of questions with the exact same stuff. I just ran it through again. We can see that there is some degradation, I think, in the answers. Like this one does get the Llama 3, Phi-3. It also gets Llama wearing sunglasses and holding a smartphone. Doesn't comment on the scarf or anything this time. What color sunglasses are blue? Planes. It still thinks that there's 12 of them there. It says that it can't do bounding boxes. Okay. The receipt stuff, did it change anything here? Now, this is where I expected that it would start getting a lot of things wrong. And surprisingly, it didn't. It got the bread price still right. It got the eggs still right. Got the peanut butter, no problem. Although when I asked it how many peanut butters did I buy, it seemed to think that the amount was 8,885 peanut butters in there. So I'm not sure where it's actually getting that number from, but clearly that's a lot more wrong than even the first one, which was said 3 instead of 4. Anyway, overall, I think the Phi-3 Vision model is definitely a model you should be looking at if you are doing any tasks that require this kind of thing. It's really a quality model, has a lot of things going for it. And it's got a very small footprint, and both in sort of full resolution, and then certainly in the 4-bit model. I'm really surprised, like I said, that this is not already in Ollama. It could be because they haven't done the conversion themselves. They're waiting on the conversion to come or something like that. Anyway, I may look at doing a follow-up with something like this in Ollama and look at doing some apps that you could actually do. So I did talk about this in one of the videos before in here. Anyway, as always, if you've got any questions, please put them in the comments below. If you've tried this out, let me know what you're using it on. I'd be really interested in knowing what people are actually using this for, or what you're interested in using this for as well. Anyway, as always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.